Hello everyone. Now we are going to see a topic phase center cubic structure in crystal structure. Yeah, let's recall what is a simple cubic, what is body center cubic. So simple cubic, it contains eight corners cubic structure, and all eight corners contain one atom. So totally 8 atoms, and this each and every atom is shared with the nearest neighboring unit cells, and we discussed about its atomic packing factor, coordination number, that and all we discussed. And the same for BCC also. BCC 8 corner atoms and one body center atom, and its APF, that is atomic packing factor, is also discussed. The formula for finding APF is volume of atoms per volume of the unit cell. So now we are going to discuss about introduction to coordination number, atomic radius, and determination that packing factor of phase center cubic structure, and uses of atomic packing factor in a real world applications. So generally now we are going to discuss about a FCC, phase center cubic atom, and all its parameters we are going to discuss, and also its applications also. So why we need to calculate the atomic packing factor? So this atomic packing factor is used to measure the packing efficiency. Then it determines how tightly atoms are packed within the crystal structure, how much amount of space is occupied by the atom, and how much amount of space is vacant, that we can measure using this atomic packing factor. Then we can relate the structure with the density, and it helps to calculate the material density and compare how different crystal types occupy space, and to predict the mechanical properties. That means it explains why closely packed structures are more ductile than loosely packed ones. Loosely packed ones, BCC structure, the atoms are loosely packed, and tightly packed means FCC and HCPs are tightly packed structures. Next, to analyze the material behavior. So useful in understanding diffusion, then what about its corrosion, then what about its resistance. So this and all we can analyze using this atomic packing factor. See, loosely packed factor, so densely packed. Loosely, what is the difference loosely packed and densely packed? That means the molecular distance, that distance between the atoms are very small, means densely packed, and the distance between the atoms are little bit high, means that is called loosely packed. And characteristics of a unit cell. So four major parameters: number of atoms per unit cell, then coordination, number of atoms. So how many atoms are present in one unit cell. So that is called number of atoms per unit cell. Next, coordination number. So coordination number is number of equal distance nearest neighboring atom to a particular atom, and atomic radius, half the distance between nearest neighboring atom. Next is atomic packing factor or packing density. It is the ratio of the volume occupied by the atoms in unit cell to the volume of the unit cell. Phase center cubic structures. So this is the phase center cubic structure, and all the corner atoms contains one atom, and all the faces, that means a cubic structure contains 6 faces, and all the faces have one atom at the center. So atoms are present like this, and the second and third pictures are seen here. So the third picture is the first picture is unit cell, and third picture is the structure of a crystal. And number of atoms per unit cell in FCC is 4 atoms are 4 atoms per unit cell, and its atomic radius is root 2a by 4. Its coordination number is 14, and its packing factor is 0.75 percentage. Next is applications of atomic packing factor. So where they are used in semiconductor conductor industries, then material science field and X-ray diffraction. So how it is used in semiconductor industry? Essential for epitaxial growth of the thin films. A thin film in the field of thin films, it plays a major role, and silicon wafers are often cut along the 100 plane. Already I explained in previous videos. 100 means X is present and Y and Z coordinate is absent. So 100 plane for device fabrication. Then material science, they are vital for understanding crystal growth, and this impacts material properties greatly. And X-ray diffraction, Miller indices help predict diffraction patterns. This crucial for material identification also. Let's summarize. So, what is FCC and what about its parameters, that and all we discussed. So, APF, atomic packing factor. So, number of atoms present, how many number of atoms present in the unit cell, that is four atoms are present in the unit cell. Then what about its radius? Radius is the distance between two nearest neighbor atom, and the formula for finding atomic packing factor is volume of each atom per volume of the unit cell. Then volume of a unit cell is here, it is the a power 3, because it is cubic structure, so its volume is a cube. And some of the curiosity challenges. So what are the questions and curiosity challenges here? So that is, calculate the APF for each crystal structures, then compare the efficiency of the packing for all the three atoms, that is simple cubic, body center cubic and face center cubic system, and explain which structure you would choose for maximum strength to weight ratio, then better ductility and corrosion resistance. So the construction of uh, direction and playing with a unit cell. So some of the assessment questions are all the questions are short answer questions. Atomic packing factor, in your own words you write it. Next, derive the formula for AP, atomic packing factor for a simple cubic structure. Then explain why BCC structure has lower packing efficiency than FCC structure. Then calculate a void fraction for a simple cubic structure and write any two applications where high atomic packing factor is advantage. So some of the references. Thank you.